Welcome to Module 11, Variable Air Volume Terminal Control. VAV terminal is not simply a damper with a room sensor. It is a coordinated airflow and temperature system that must serve comfort, ventilation, pressure, noise, and equipment limits. In this module, we will coordinate zone states, airflow set points, the local damper loop, minimum airflow, reheat, fan-powered terminals, diagnostics, and AHU reset requests. The goal is to understand how one terminal affects the room and also the larger air handling system. The objectives are practical. Learners should define the zone states used by a VAV terminal, coordinate airflow set points with damper control and reheat, and understand where minimum and maximum airflow values come from. We will diagnose airflow sensor and balancing problems, review fan-powered terminal logic, and identify which terminal signals are valid enough to support AHU reset strategies. The core concept is that the VAV box coordinates multiple decisions. Zone temperature determines how much air is needed. The airflow loop uses measured airflow to move the damper. Reheat should be coordinated with heating state, airflow minimum, and discharge limits. Damper position by itself is not delivered airflow. VAV terminal is successful when temperature, airflow, ventilation, and supervisory demand are all believable. This is the relationship to remember. Zone temperature, set points, and operating mode generate an airflow set point. A separate local airflow loop modulates the damper to achieve measured airflow. Reheat is coordinated after airflow is stable and after the zone is truly in heating state. This separation helps troubleshooting. A warm zone may need more airflow, but the damper loop and duct pressure determine whether the box can actually deliver it. A terminal sequence should clearly identify its operating state. In cooling, airflow rises from minimum toward cooling maximum. In deadband, airflow remains at the approved minimum and reheat is off. In heating, reheat modulates and airflow follows the approved heating strategy. In unoccupied mode, setback, setup, or shutdown rules apply. Smooth transitions, hysteresis, and bounded ramping help prevent cycling at state boundaries. Minimum airflow is not just an energy number. It may be required for ventilation, heating distribution, pressurization, diffuser performance, process needs, or approved design limits. Maximum airflow must also respect cooling capacity and noise. Reducing minimum airflow may reduce reheat, but it can also violate ventilation or space requirements. Any change should be documented and connected to the approved design basis. Reheat should usually remain off during cooling and deadband states. In heating state, the sequence may reduce cooling airflow toward a heating minimum and modulate reheat to maintain the heating set point. Discharge temperature limits may be needed to avoid stratification or occupant discomfort. If reheat is active during cooling demand, the terminal may be wasting energy or fighting the air handler. Verify the state, airflow, reheat command, and actual heating availability. Fan-powered terminals need explicit fan logic. Parallel and series boxes behave differently. The sequence should define occupied fan mode, heating fan enable, proof where provided, minimum runtime, plenum air temperature considerations, primary air dependency, and failure response. Electric heat requires approved safety interlocks and airflow proof. BAS logic supports operation, but it does not replace factory high-limit protection. Occupancy sensors and window contacts can improve performance when the sequence is clear. A central schedule may define the base operating period. Local occupancy can move the zone to standby after a persistence delay. A window contact may disable local heating or cooling after a delay. Avoid rapid mode switching from brief motion loss. Alarms should be used when an operator can reasonably take action. Terminal diagnostics must use context. Low airflow with the damper near open may indicate low duct pressure, a blocked inlet, a failed actuator, or a bad airflow sensor. High airflow with a closed damper may indicate leakage, scaling, or balancing problems. A warm zone at cooling maximum may be caused by insufficient airflow, warm supply air, or load above design. Do not blame the terminal or the AHU until the evidence path is complete. Terminal data can support static pressure reset, supply air temperature reset, ventilation calculation, zone demand summaries, and fault detection. But the data must be valid and representative. Exclude boxes with sensor failure, overrides, commissioning mode, communication loss, or abnormal local conditions. A single bad terminal should not drive the entire AHU to maximum pressure or inappropriate supply air temperature. This worked example shows the basic cooling to heating transition. When zone temperature is above the cooling set point, the airflow set point moves from minimum toward cooling maximum and reheat is off. When zone temperature is below the heating set point, airflow follows the heating strategy and reheat controls heating demand. In deadband, airflow remains at the approved minimum and reheat is off. The real project sequence must add occupancy, discharge limits, fan type, signal validity, and reset behavior. Best practice begins with standardization. Use common point names, airflow units, state labels, graphics, alarms, and commissioning forms. Verify airflow tubing, scaling, balancing values, and damper travel. Make cooling, deadband, heating, standby, and fault states visible. Protect approved minimum airflow. Exclude failed boxes from AHU reset summaries. Commission the terminal locally before using its data for supervisory optimization. Let us summarize. Zone logic should create an airflow set point, not a raw damper command. The local airflow loop controls the damper using measured airflow. Minimum airflow must protect ventilation and approved space requirements. Reheat belongs to the correct heating state and should not fight active cooling. Finally, only validated terminal data should support AHU reset requests. Before moving on, answer the knowledge check questions and review one real VAV box trend if available.